In this video, we will see dry run of the code. So now let's see a quick dry run of all the codes, right? So now I won't take anagram and nagram as the example because we have already covered so much. So let's suppose I have one S with the one listen. Okay, this is word. And I have one T that is with one silent, and both are anagrams of each other. As you can see, both are anagrams of each other. All the frequencies and the character is exactly same, right? So what I will do, I will create one object. This is my object, okay, with key and value, okay. So I will start from 0. So 0, 1, 2, 3, 4, 5 inside this thing. And I will check is L is present in my object. No, it is not. So I will create L with frequency 1. Is I is Then I will check is I is present in the object? And no. So I will create I with frequency 1. Is S is present in my object? No. So I will create S with 1. Is T is present in my object? No. So I will present T with 1. E is present in my object? No. So I will present E with 1. Similarly, I will present N with 1. Okay. Now let's suppose there are one more character. And here also, here it is not. Okay, because I just want to show that both are not anagrams. So it is 6, it is here. And what will be the frequency of n? It will be 2 now. Okay, because I will come under the else condition and I will update it. I will update the same characters. So this will be my final frequency. Let me just enlarge it. So this will be final frequency here. So I can say that this loop is done. Then what I will do, I will run in T, right? So this is my T 0, 1, 2, 3, 4, 5. What I will do, I will basically check if it is present. S is present. Yes, it is present. If it is not present, then I will directly return false. Okay. Think that all these letters are in decreasing order, like in lower case, right? So don't think S is capital. No, all the letters are in decreasing order, in descending order, or I will say lower case. So here I will check if L is present. Yes, it is present. So I will decrease the frequency by 1, that it will be 0. But if not L, first S, I will pick this element. Is S is present? Yes, present. Decrease the frequency by 1. Then is I is present? Yes, present. Decrease by 1. L present? Yes. Decrease by 1. E present? Yes. Decrease by 1. N present? Yes. Decrease by 1. So it will be 1. T present? Yes. So decrease by 1. So it will be 0. Now this is also done, right? Now I will come here and I will check, okay, is all the values are 0, 0, 0, 0, 0. This is 1. Okay. So what I will do, I will return false, and here I will return false. Yeah. So this is how you can implement this approach. This is one of the approach that we have discussed. Now what will be the dry run on the second approach? Now let's check out the second approach. So what second approach is all about? So we need to create one array. So this is my array with the 26 elements and all the elements are filled with 0. Okay. Then I will come here. I will start from 0. So my I pointer will be here. Okay. And I will take s dot char code at I. So I is at L, right? So I will take L. I will take L minus A, right? I will do minus A. So what is the position of L, right? So the position of L is 108 and A is 97. So we will get the difference is something as 11, right? So I will go to 11 and I will update the frequency. So I will go to 11 and I will update the frequency by 1. Okay. Similarly, my pointer will move to I, right? So I will have I minus A. What will be the difference of I minus A? That will be 8. So I will go to here and update the frequency by 1. Similarly, right, I will check S, right? What is the difference between S minus A? So the difference of S minus A will be 80. So I will simply move to the 18th index and I will update the frequency by 1. Now let's do a bit fast. So I will check here t, right? What is t minus a? So t minus a, that is 19. So I will update the frequency here by 1. Then I will get e. What is e minus a? So e is 4. So I will update the frequency this one by 1. Then I will get n. Okay, what is the frequency? N minus a difference, that is 13. Okay, so I will update the frequency 13 by 1. Here I am getting again n, right? Again n. So I will again update it by over 13. So it will be now okay. So now what I will do? Now I will do, this loop is complete. This loop is complete. Okay, up to this, I will come to here and I will decrease it. So S, what is S minus A? 18. I will move to 18 and I will decrease it to what? Decrease it by 1, so it will be 0. Then S is done and I will move to I part, I minus A, 8. I will move to 8. S minus I minus A, 8. We have not updated to 8. Like here, 8 should be updated to what? Okay. Now this is the difference. What? I guess I have updated 9, right? It should not be 9. It should be 8. Right? So it will be 0. And I minus A is 8. So again, I will decrease it by 1. So it will be 0. Okay. I is done. Then L minus A, that is 11. So I will move to 11 and decrease by 1. So it will be 0. Then I will check E minus A, 4. So I will decrease the 4 by 1. So it will be 0. Then I will get N, right? N minus A, 13. I will move to 13 and I will decrease by 1. So it will be 2. Oh, sorry, 1. And if t is there, t minus a, that is 19. So I will move to 19 and I will decrease by 1. So it will be 0. And that's it. That's the limit of the loop, right? That's it. And now what I will do, I will check all my elements, right? Here, I will check to array dot length. If there is something that is not equal to 0, so this is 0, this is 0, this is 0. All the elements are 0 except this one. This is not equal to 0. So I will return false. I will return false here. And that will be the end of the loop, right? So this is the dry run of approach 1 and approach 2. And this is how you can solve a very basic and fundamental problem, yet important, because this is asked. There's a fundamental question in many interviews, that is valid anagrams.